All right. Hello, everyone, and welcome to a fun panel on artificial intelligence, AI, and its impact on software engineering. I'm Joe Duffy, founder and CEO of Pulumi, and I'm joined with some frankly incredible colleagues that I'm sure will bring a great perspective to the conversation. Hopefully a little bit of controversy, but we'll see. So I'd love to introduce everyone, starting with Amanda Silver, who's Corporate Vice President in the Developer Division at Microsoft. And I've known Amanda for many years, so really excited to have you here today. Next is Baiyang Liu, who is CTO and co-founder at SourceGraph, amazing company doing innovative work in sort of developer tools and code search, and we'll get into some of that. And then Luke Hoban, CTO at Pulumi. I've had the pleasure of working with Luke on Pulumi for about 6 years now. It's been fantastic, and bring a little bit of the perspective of the cloud into the conversation. And so thank you all for being here. Definitely looking forward to the conversation.
Yeah, thanks for having us.
Thanks for having us.
Great to see old friends.
Definitely. Yeah, it's interesting. The world of developer tools is surprisingly tight-knit and smaller than it would seem.
Very true.
Maybe on that note, to get started, I'd love to do a little bit of an icebreaker question. What was your first exposure? I mean, the year's 2023. There's this thing called artificial intelligence that seems to have just arrived overnight. But in reality, honestly, it's been in the making for many, many years in the industry. Dating back to perceptrons and, research at MIT and machine learning over the years. And I'm curious just to hear, what was your first exposure to AI, and has the industry sort of kept up with, did you have an aha moment when you first, learned about AI, and has the industry surpassed your expectations, been slower to reach them? I'm just curious to hear that sort of anecdote to start. Maybe start with you, Amanda.
Sure. Yeah. I mean, other than the talking doll that I had when I was a little girl, that you would pull a string and she would give you words of encouragement from my uncle. That was very, very wonderful. But no, I mean, in college, I took a class on neural networks and their impact on computer science. And I think, in that generation, just taking the cognitive sciences, line and merging it with the computer science line, it was pretty controversial and actually not exactly a well-attended course. But I did learn about neural nets in that era in the late 90s, dating myself here. But after that, I really didn't have any exposure to it until about the early aughts, when we actually did an experiment with MSR to see if we could help programmers learn to program using neural nets. But at the time, the compute power was just not enough, and we needed to obviously run everything on local dev boxes, and there just wasn't enough compute power for us to actually get it done. And so the project failed after about a year and a half.
And from our failures, we often learn, what works, what doesn't work, and seem to have come a long way since then. Great. Baiyang, what about you? What's your first story?
Yeah, so I can definitely empathize with the failures that Amanda just mentioned. So my intro to machine learning was actually kind of intertwined with my introduction to programming itself. So I got into it in college. This was around 2007 to 2011, and I was actually my what do you call it? Like specialization in college was actually machine learning, and so I did a fair amount of machine learning. A little bit of machine learning research too. Actually ended up publishing a paper in CVPR back in 2010, in kind of like the ancient times of AI, relatively speaking. And it was fascinating to me. I think the topic area was like a beautiful union of a lot of the kind of like discrete mathematics and computer sciencey concepts, united with some like the elegant, continuous math and linear algebra that a lot of us learned in school. And it was just this idea of being able to model these very unstructured forms of data, such as vision or speech, just through multiplying lots of numbers together and then adding them was really fascinating. Now, like Amanda said, in those days, machine learning, I feel like an old man in those days. In those days, the models and the kind of like state of the art was very different than today. We had a lot of difficulties in the lab that I was working in, just getting object detectors to pick out cows from fields of grass. And I remember, one of the things that we learned in the introduction to machine learning class was that, neural nets were these things that we tried back in the 90s, but they didn't really work that well. So, don't use them anymore. Now, of course, that's all changed. And the kind of latest developments on the vision front, as well as, large language models, it feels like a really awesome homecoming. And it's just amazing to see the progress that's been done in the field since, I first encountered it.
Definitely feels like we kind of passed the tipping point at some point along the way, for sure. Somewhat recently.
They called it the AI winter, right? Mm-hmm. So now what are we in? The AI spring again?
Yeah. I feel like there's been multiple AI winters and summers, so it's seasonal, I suppose.
Indeed. And what about you, Luke? What was your kind of first exposure to AI?
Yeah, so I think, kind of like everyone else, college was sort of the exposure to some of the fundamental pieces. And for me, I was actually doing a master's in hardware and sort of silicon design, and was doing a class where we were kind of a project to go build some piece of custom silicon. And for whatever reason, the group I was part of chose to build custom silicon for a neural network for handwriting detection. And so this was back, a while ago, as others have mentioned. But building custom ASIC for digit detection using neural networks back then. And in that perspective, I just thought, we were being told the same thing. Neural networks are mostly a toy. They're mostly sort of a fun thing. They were just an excuse to kind of go build this. But kind of actually building that, and I think I still have the chip, somewhere around in my house that we fabbed for that class. But that, was my exposure to kind of going very deep on a very kind of narrow piece of that. And I'd say over the last, 20 years or so, it was one of those things where it just went a lot slower than I might have expected for a long time, and then a lot faster than I might have expected for the last, 2 years or so. And I think, for me, kind of paid attention to some of the things outside of the developer tools space. There's obviously progress on, text to speech and on vision and some pieces where you were seeing it actually show up in the real world. But in my domain and in our domain generally here, I think of kind of developer tools, you weren't seeing it show up much. And I think really the biggest reintroduction was when Copilot came out, and just seeing, wow, this is actually really good. And this is really going to have a big impact on the developer tools experience. And what other things should we be thinking about in terms of what's possible? And so even though it certainly wasn't the first time I was exposed to it, it was the first time I sort of really internalized that this was going to change developer tools.
Yeah, for sure. That's a great segue into the next question I have. It does seem like with the introduction of Copilot, ChatGPT, SourceGraph has Cody. It seems like AI generally has seemingly taken a step function in its ability to generate code at the very least. And I'll talk a little bit later about potentially some other opportunities with software engineering generally. But, what are some of the most exciting breakthroughs you see there? Is it, hey, it can generate code. It's actually, correct. How has that changed the programming landscape for the better from your perspective? And maybe start with you, Amanda.
I think we're still really seeing what the impact is going to be, right? We obviously have kind of the greatest longevity in a sense with something like GitHub Copilot, but basically applying it to the programming languages domain. And we obviously have, a lot of history as well in terms of like image generation thus far. But, we're really at the infancy in terms of looking at how it can be applied to other application domains and all different kinds of other domains that we have yet to apply it to, and kind of thinking about like how people are going to build the next generation of intelligent apps. I think in the programming languages domain, we're certainly seeing already that it's changing the way that people think about how they're going to write and construct their applications, where they spend time. It's forcing us to kind of think through, well, what do we want the future to be? Right? What do we want the experience of being a developer to feel like? And then also like, how do we think about what what is the value that developers bring to the organizations that they support as well, and how do we get crisp about what is the value that they want to bring, and also that the organizations are really designing for them to bring. And so, from my perspective, I think what I've seen in my experience is that, developers really like to create, they like to innovate, they like to solve problems. And so the more that we can actually use AI to get them to that point where they're always inventing and always kind of, creating and solving that next problem, that's really the sweet spot. And I think that's also what the organizations that employ many of these developers want, or, founders want as well, is to kind of focus on the code that's really unique to that particular individual and the business that they're trying to solve, or the organization that they're trying to support. So it's really kind of just getting into that sweet spot. And then the other thing is this question of like focus, right? For developers to really do the creative work and the deep work that they need to do, they actually need to maintain this sense of focus. And I think there's a lot that AI can do to actually get them into that deep domain, whether it's building the context that they need, or it's maintaining some of the cognitive load that they need to actually reason about problems, or it's, just getting them started. The equivalent of writer's block exists for programmers as well. And so I think we're certainly seeing that also be an interesting dimension of why people find it to be useful.
Yeah, that definitely resonates. We launched this PulumiUP tool, which often I say the same thing, writer's block. It's the blank page problem. It's how do you even get started? And then once you get started, code completion and Copilot are definitely kind of taking you to the next level. I'm curious, Bayoung, from your perspective, what are some of the areas where today maybe some of the LLM-based code generation is uniquely good, or potentially, areas for improvement?
Yeah. So first off, I just want to agree with everything that Amanda said. I think we're currently living through a revolution, and the pace of innovation is just enormously high. Like Copilot, I think was a game changer, and it kind of demonstrated just a glimpse or like the very tip of the iceberg of the possibilities of language models as applied to software engineering and coding. I think we're living through kind of like a Gutenberg moment currently, where as of 2022, the ability to read and write source code was limited to a tiny kind of like priestly class of individuals known as software engineers. And with the advent of large language models, we now have the ability to build tools that place that power into the hands of basically everyone. So, just one anecdote, like a piece of feedback that came in recently. One of our users of Cody emailed us. It was this fella based out of South Africa, and he kind of introduced himself. It was a very long email. It basically said, lost his job at kind of like the just after like COVID started. A lot of the pandemic influenced kind of economic turmoil, and so he set out to learn to code. And he tried like all the coding boot camps, a bunch of like different education tools, and then a couple months ago found Cody and mentioned that like Cody was like the single most like valuable tool for teaching him how to code, to the point where now he's got like a working model of like Python, and is coming through these like bash scripts that he's trying to fix now. And it's basically guiding him through the process of like teaching himself to become proficient at reading and writing source code. And I just think that speaks to the possibility of the opportunity in front of us, especially moving kind of beyond just the initial application of language models, which is more kind of like a completion oriented, GPT-3 and a lot of these other initial language models of the current era were oriented towards completing large blocks of text. Now with like the chat-based models, there's more of kind of this call and response model. But really, I think like the key innovation that came about that enabled this kind of like step function increase above the completion oriented abilities was this so-called like chain of thought ability that emerged. that gives these language models a semblance of reasoning. So they're not just kind of like auto-completing the preamble or the preface of text that you give them, but they're actually able to like, reason about different things and combine concepts together in ways that seem to be at least somewhat logical. And that's something that we're kind of focusing on now, because when you think about like asking questions of your code base and getting answers, a lot of it is fetching the relevant context and then placing those into the context and having the language model kind of like reason about the different components and tying those together into an answer for the user. So I guess I'm rambling a bit, but to answer your question, I think like the big potential for us, the way we see it is, fetching context and providing language models with the proper context to arrive at useful and correct answers. And that's kind of the revolution that has occurred in the past couple months. And that's where we think a lot of the future promise of working with language models lies.
One of the things I was actually very interested in kind of building on top of that Bayoung mentioned, because it's actually interesting how, a lot of this is about kind of how we apply AI to developer tools, and how we build new developer tools experiences kind of that are powered by AI. And I think there's an enormous amount of that. And I think, we've been working, each one of us is working on different aspects of that in different contexts. But I think there's also an aspect that's really interesting about how, Van was talking about the chain of thought, pieces, and there's been a lot of kind of improvements in how we think about that. But is how we apply kind of developer tools to AI, right? And how we think about, programming these things and building systems on top of these technologies, and what that means for developers going forward. And I think all of us are also experiencing that. This is a very different kind of thing. These systems are different kinds of software to go build than what we've been used to in the past. And the way that we approach building those, the way we approach testing that is very different. And so I've just been very interested to see how that's evolving, and how we're all learning a new set of skills for how we go build a different kind of software. Whether that's, kind of how do you program LLMs effectively, right? What is the structures you put on top of that? There's the chain of thought, like you mentioned. There's, kind of how do you provide guidance around these things? How do you provide testing? Lots of interesting pieces there. Even the sort of programming models for kind of how you go after authoring these models in the first place. There's a lot of progress being made there. And I think there's also the aspect that just sort of code is in some sense the ultimate tool. And so a lot of what's happening now is around how do we give the power to these large language models to use tools. And I think, ultimately that bottoms out on give them access to code and the ability to run code in various different contexts. And so thinking about how we enable these AIs to be developers as well, not just to sort of spit out code for us and then do the LLM thing, but to actually kind of leverage tools and leverage, software and code. And what does that mean? I think there's just some really fascinating kind of questions and things that we're all discovering as an industry right now.
Yeah, there was the so-called like Toolformer paper that was written that has engendered a bunch of cool, interesting applications. A lot of like editor extensions popping up right now, and editors, frankly, that use the language model to invoke different tools and figure out like what tools to invoke to get the user the right answer. And I think that area carries a lot of potential. This kind of like auto, I don't know what you would call it, semi-autonomous invocation of tools and executables to fulfill user requests. I think there's a lot of promise there.
I mean, in some ways, that isn't that far from programming, right? Because, in essence, when we think about what it takes to actually write an app, you're assembling a set of APIs. And one of the things that these AI models are super great at is actually suggesting what SDKs and APIs you need to invoke in what order to get the thing done that you need to get done. And I think, the thing that's interesting is writing code is only one dimension of what it actually takes to be a developer. You also need to invoke the right, command line utilities. You need to, set up the dev machine in the right way, or your container in the right way, or whatever it is, your topology in the right way. And that's also a series of incantations that you need to actually go through. And so doing that inventory and kind of keeping up to date on what are the best tools to accomplish a particular task, that's something that's very challenging for developers to keep up with. And so if that's something else that, AI can really help with, I think that would be incredible utility as well.
Yeah, imagine never having to learn like a command line tool again, like not having to learn like the Git API or the, grep API or whatnot, just being able to like describe what you want in natural language.
Yeah, exactly.
Yeah, one related question that sort of builds on that is, some contrarian viewpoints have been, hey, generative AI has really just made it easy to copy and paste, and it's accelerated sort of the copy pasta syndrome of just copying code all over the place. And wouldn't it be better to build better abstractions? And but potentially the answer is it leads more down the path of automating entire systems rather than just thinking in terms of one software component at a time or one software library at a time. Do you think in hindsight, in a few years, we'll look back and we'll think on this period as a brief moment in time where it was all about generating code, and that it's actually more about generating entire systems from here? Like, what does that look like, and how fast do you think that will accelerate? And anyone can answer. I'm just curious.
I think that's really similar to a common question that I get asked from new hires and college grads and people who are in the middle of their studies right now. They're kind of like, given this sea change that we're seeing in the industry, how should I think about the skills that I actually need to go acquire? And my answer to them is, I think systems thinking is the skill that is going to be, it doesn't matter how good the AI gets, you're always going to need systems thinking to actually reason about the set of systems that you're actually assembling and how to make sure that they're hitting the quality and kind of the functionality that you're looking for.
I think there's sort of two pieces in my mind, kind of build on that. Like, one is that the from pure like code generation perspective, I think, generative AIs will work at the level of abstraction that we give them, right? If we give them the ability to use these APIs or these tools, they'll go generate code. And if the level of abstraction of those APIs is too low, they'll give us giant piles of code that we have to copy paste around, just like we did with Stack Overflow or with whatever else. And so I think it just sort of challenges us to build the right abstractions for tools that can be, substantially more productive, can generate substantially more complex things automatically for us. And it's going to push us to sort of raise the bar on abstraction. But I think that's sort of a challenge that we've had, and a lot of us have been pursuing, even independent of AI, is how to build the right abstractions and how to raise the abstractions for certain domains. And I think this will encourage us to continue doing that. But I think to the point kind of you made, Joe, in the question as well, I also think this idea that these AI tools are just about generating code that you copy paste is a very limited view of what this is likely to be over the next few years, right? I think that's an important starting point. The kind of Copilot experiences or PulumiUP experiences or Cody experiences today are largely about that, about generating small amounts of code and putting them right in. But I think giving more autonomy to these tools, having them generate entire PRs that you can now say, I want to review this and merge it, or solving whole problems or generating whole code bases, still with some guidance from a human and still as tools that humans use, but much less about just copy pasting and more about kind of atomic actions that these things can take using code.
Yeah, I agree with both Luke and Amanda here. I think the space is innovating very quickly, and the ecosystem is definitely moving beyond just kind of vanilla autocomplete. I would say, if all we did was stop at just AI enabled autocomplete, I think the criticism would be on point. I think it's there's a valid question of if you think that the way to measure developer productivity is not lines of code written, then that should also apply to the robot that you get to write your code as well. And so the way to measure the value of a tool is not so much oh my gosh, how many lines of code did this auto generate for me? It's more about the features that you delivered, and in some sense, the less code it writes, actually the better, because then there's less code to kind of reason about and understand or potentially break down the road. And so, I think you're preaching to the choir here to a certain extent. SourceGraph's mission, one of the reasons we created it was we felt that reading and understanding code was probably where most developers were spending their time already, and maybe like the upstream problem to address. You have to understand the context of the code base before you get to hacking on features, because you got to know what you're building, how to integrate it into the existing system before you can decide to what you need to build. And I think that's where a lot of the effort should be directed moving forward. And if we're going to be living in a world where most of the code in the world is actually AI generated, and I think that's a very real possibility in the next couple of years, then I think a new problem emerges, which is how can we enable human developers who are ultimately responsible for the systems that we build to go and make sense of all that AI generated code, go and make sense of the orders of magnitude more source code that will exist in the world and interact with each other in very interesting and unforeseen ways.
I agree completely with everything that you just said. I have a possibly controversial analogy here, and I'm curious what your take is on this. In a sense, I kind of feel like we're taming a beast. Do you know what I mean? Like there's this thing that's, we kind of can anticipate its moves, but it's also something that's a little bit out of control. And we're trying to kind of figure out how to actually kind of gird it into the behavior that we want it to take. And so I'm curious, like, does it feel the same way to you guys? And if so, obviously, like I've been to many rodeos, but I've never actually attempted to tame a beast. But I'm curious, what does it feel like to you guys?
No, I think it absolutely is. And I think there's sort of a couple of senses. One in a sense of just like the rate of progress. And so there's sort of just a taming that, how do we sort of keep up with that rate of change? But there's also kind of the capabilities, it's very easy to close your eyes and sort of look a little bit ahead and just imagine, and it's not clear which ones of them will become true, but it's easy to imagine things that are just like way past what, we all kind of think of and conceptualize of in terms of what these things are capable of in relatively short periods of time, in terms of, generating, like to Deban's point, generating enormous amounts of code that we couldn't even read and reason about, right, as a human, or, automatically running code, right? If you let these things generate code, and then you let them run them in an appropriate sandbox, what are they capable of doing if you give them access to all these capabilities? And it's just easy to let your mind kind of run, your imagination go kind of wild here. And so then thinking about, well, okay, with all that stuff that's theoretically possible, some of it possible to go think about building now, some of it, possible to think about go build in the next year or two, kind of what do you do, right? How do you figure out how to, which pieces to go after first, kind of where to invest, and kind of what is going to be the most exciting things you can do with that. So, yeah.
Yeah, I would, be even more controversial than what Amanda said. I think like the beast was already here in terms of the mountain of source code inside every organization. If you were to ask, average developer inside any organization, hey, how does this one piece of code, work? What's the chance that person will actually, know off the top of their head or be able to give you a coherent answer versus, that was written by so-and-so a long time ago. No one's touched it since they left the company, et cetera, et cetera. And I think what has happened in some sense is with the advent of generative AI in developer tools, we've taken that beast and just thrown it like it's almost like if you ever watched Power Rangers as a little kid, like we've given the beast like the magic pill that turns it into like a giant, tall as a building Godzilla type figure. And it's powerful on the one hand, we can harness that power for good, but at the same time, it's also kind of scary in terms of, if more than half the code written in your organization is being generated by an AI, what semblance of code standards does that AI have? What sort of guardrails are in place to give you confidence? Because it's not like at the end of the day, you can go and like fire the AI or blame the AI. The AI has no kind of agency or accountability. It's ultimately humans that still have to step in and take responsibility for all that. And I think we as an industry are kind of scrambling to arm the humans in the loop to go and with the ability to go and like tame and wrangle this beast and funnel its powers in a productive fashion.
So it pains me to even ask this question because I've spent the better part of my career working on programming languages, and I love programming languages, but are they even necessary anymore going forward? Or do programming languages only exist as a target for the AI to produce code? And if so, is the current state of programming languages the ideal target for the AI to work in? And honestly, it doesn't even matter. I mean, you look at JavaScript and the web, and if you were to design sort of an assembly language for the web, you end up in a very different place from JavaScript, and yet JavaScript has done just fine. But yeah, what do the role of programming languages play going forward? And is that different than they have historically?
Well, I think there's still like the interface between kind of the AIs and everything else, right? Between the AIs and kind of humans, like, just in the same way that natural languages, one of the reasons why large language models have been so successful and so impactful is that they sort of become this interface between natural language, English, whatever kind of language someone speaks, they can use and to sort of communicate with in both directions, one of these AI tools. And I think the same thing is true for the programming languages. And it's actually sort of interesting, like, I've often wondered, hey, will this change the programming languages we use to be something that's better for talking to machines in a sense? And I think if anything, the learning from large language models is almost the opposite. It's that what's happened is that's become a non-issue, right? These things are so good at learning our languages, including our programming languages, that we don't have to go contort our languages to talk to these machines. They've contorted themselves to be able to talk to us, right? And that's what large language models have done that I think has been so surprising to so many of us. And so I think, and they're trained now on enormous amounts of Python and JavaScript code, and so they understand these languages just unbelievably well, right? And so they're figuring it out quickly. I think, though, there will be interesting things in terms of how languages evolve. I think some of these things I kind of referred to earlier, like how do we build, what are the new programming languages that we will build to be able to program LLMs effectively, right? And I do suspect there'll be some interesting things there where the programming languages to build this new kind of software are going to look a bit different, just because the nature of the problem is so different. Probably have more natural language in it because these tools are so much driven by natural language. And I also think that it is possible that we'll see kind of actual languages change because they are less about a compiler understanding them per se, and more about an AI model being able to understand them and reason about them. And that might loosen some of the requirements that we have on what programming languages need to be.
I think there's maybe a rough analogy you can draw between natural languages and programming languages now in the age of large language models, and kind of the programming languages, so-called high-level programming languages like TypeScript or C++ or and any of the major programming languages today, and assembly language. Before high-level programming languages were invented, you had to write just raw assembly, and that was kind of what you did to get the computer to do what you wanted. But then high-level programming languages came along and they kind of abstracted that away and presented a more human friendly interface for instructing the computer. And likewise, now with large language models, natural human language, English or French or whatever, that's arguably more natural for instructing the computer for probably like 99% of use cases. So I would say the analogy holds roughly, with the caveat that I still think for situations where you need to be very precise about what you mean, it's beyond like, hey, order me an Uber from here to, downtown. Like that's easy enough to interpret. But like, if you're working on some critical piece of infrastructure where you need to be very precise about how it's iterating through this thing or like manipulating the memory, I think that there is no substitute for the precision that programming languages give you for describing exactly what you want. And so I would maybe the one objection I would raise to my own analogy is perhaps there will still be it will be a more commonly taken escape hatch to go from natural language to the underlying generated source code than how many of us programmers actually look at raw assembly today? Probably vanishingly few. But I do think that with this natural language interface, that there is enough ambiguity in that every now and then I could see like a human trying to like produce software, jump into the layer below and be like, let me examine, precisely what it's doing here because I need to clear up some misunderstanding.
Yeah, I agree with both of what you guys said. I both think that programming languages themselves are going to actually evolve because just the types of problems that we need to reason about and kind of the abstractions that we need to reason about are now inclusive of, stochastic models. And we don't really actually have good programming languages to kind of reason about that. And so we'll need to kind of go and fill that. But the other thing too, I agree with you, Byung, on the point that you were making around, yes, a vanishingly few people do assembly programming. But I think the analogy in some senses is kind of what's happening in the low code space, right? Where essentially what we've done is we've empowered a ton of people who don't necessarily have, traditional background and traditional training in computer science to actually successfully be able to create applications. And it turns out for business process automation and other kinds of workflow automation and other kinds of very simplistic forms over data types of applications, honestly, like you don't really need sophisticated, programming language experience to be successful with that. And I think that that's probably the space that's going to be the most disrupted by natural language interfaces in terms of generating code. I think the thing that we still don't have as a part of these stochastic models thus far, but I also think this is something that's on the horizon, is we don't yet have, we can create programming languages, we can generate code and create programs, but we cannot yet inspect the data structures in some senses that those resultant programs create unless through execution. And in a lot of senses, what programmers do is they reason about abstractions. They create abstractions through code, and it's really the manipulation of those abstractions that is the act of coding. It's not the syntactic, transcript that's the interesting part. It's the reasoning about the abstractions. And so I think that's going to be the next interesting domain for us to go tackle here is how can we help developers and systems thinkers reason about that next level, higher level abstraction.
Yeah, and to your point earlier, Amanda, about systems thinking and systems design being the crucial skill, I 100% agree with you. I think if I were to make kind of like a grand sweeping, probably indefensible position, I would say something to the effect of, like the fallacy of developer tools for the past 20 years has been we've been solely focused on the task of writing code, making that easier and more enjoyable. And we've completely missed, underinvested by an order of magnitude into tools that enable people to read and understand code. And that's been fine so far because as a developer, you kind of been able to say like, look, my job is to write code. You don't pay me to sit around and read code. I write code to build the features. And writing code is very fun. You're kind of in the zone. There's kind of like a dopamine ladder that you get to climb as you're working your way toward, making the test green or making the feature work. You ship it, you understand the code, at the moment that you've just written it. And then, maybe you forget about it later, but that doesn't really matter because, you got the feature across the finish line. You got the credit for the work that you did. And then, some other person maybe has to come by later and debug some issue and thing that you wrote. Now, if you had the AI generate most or all the code for that feature, now all of a sudden, like the real crux of the problem becomes painfully clear, which is here's some code that existed. It came from somewhere. Maybe it came from a human. Maybe it came from a robot. But you need to figure out something is wrong with your application. You now need to figure out like what is going on in the source code, how the different pieces interact together, and what's kind of like the right mental model for making a critical update. And so if anything like this, it makes it painfully clear that our job as human creators of software is not so much the kind of minutia of writing out the specific, lexical tokens that equal semantically valid source code, but more about like understanding high level bits and pieces that fit together, the data structures, the algorithms, and how those all kind of combine together to provide user value.
Yeah, it's funny. As you were talking about this, it made me think of terrible analogies that would date me significantly. But you think about like VB6, right? Like you operated at the level of abstraction of a UI and UI widgets, but then you always had code behind if you had to go drop down and debug something or extend something. And it's not too hard to imagine the sort of analogies that do similar things at the level of abstraction of AI. And it's actually super exciting to think about that and dream about that. I think down to just a couple more questions. Amanda, you mentioned earlier, people ask you all the time, folks that are in college or, new in the industry, what would you advise people, like how to even get started? Forget the role that programmers play going into the future, but this is a very fast moving area. And, Luke was mentioning things in Bayang, like LangChain, and like, how do you even get started and how do you stay on top of how to be productive in this new world?
It's a great question. And I wish I had the aka.ms link I am supposed to be remembering and mentioning right now, but I can't. But what I would say is actually, I think that's one of the most exciting dimensions of the AI itself is, this point of democratizing kind of access to learn, to the point that Byung was making earlier. Today we have a situation where there's a ton of people who want to learn how to become, involved in the tech industry. They want to become programmers. They want to become developers. And we're really limited in terms of the availability of even teaching assistants, right? Because what happens today is that the class size is limited based on, the number of teaching assistants that are available, and teaching assistants prefer to go into industry rather than to teach the next generation of students. And so the result is the pipeline of professional developers is pretty limited today. I think what's incredible about these AI systems is that they actually can be helpful utilities to learn new domains. And that can include the domain of programming itself. So I would say a great place to get started is actually just to go get something like GitHub Copilot and Visual Studio Code and just ask it a simple question like, how do I build a website? And I think you're going to kind of follow down a path that will actually lead you to a successful authoring of a website.
Yeah, I think there's also an aspect that I think a lot of folks are, well, at least there's a common sort of idea out there that, hey, these things are going to take all the developer jobs, and it's not going to be a thing left for developers to do, and hey, like at some point in the future, who knows? But I think in the foreseeable future, I think these things are just going to be amazing tools, right? And then the kind of experiences Amanda mentioned for kind of learning, the kind of things Byung was talking about for kind of, developers at scale, kind of using these productively to understand large code bases. These are just going to be tools to sort of, accelerate your craft in a sense. And you can use them where they help you, and you can not use them where they don't help you. And I think kind of just for folks kind of getting started, just thinking about them in that way, like think about how can I leverage the tools that are available to, to my benefit. Maybe people who've been in the industry longer are more reticent to go use these. So you have this sort of advantage of being more open-minded and not having patterns you've built up. And so you can kind of mold yourself around what these new tools are that are available. And I think, people have given examples here of some amazing kind of ways that folks have learned using these. But I think that mindset that these are really just tools that you can use to accelerate your own ability to build with software.
Yeah, I would agree with both prescriptions. To the question of, is it still worth studying computer science? I think the answer is unequivocally yes. The basic principles, the important high-level concepts are still useful, and they're going to be even more useful as the amount of source code and the number of developers in the world, grows by orders of magnitude. And so by going deep into those concepts, you set yourself up to be just like much, much more valuable in a world where that skill set is going to be powering most of the economy. Agree with the kind of like learn by doing sentiment. Like the best way to get a practical feel of how technologies are evolving is just by go and playing around with them yourself. Like go build something and try to use these tools at your disposal. To Amanda's recommendation of using Copilot, definitely use Copilot. It's great for kind of generating like snippets of code that map to common pieces of functionality that you might not want to read through the docs to spin up. I would add, of course, Source Graph Cody to that list. We're already seeing it used by people who are just like learning how to code, to ask specific questions about specific libraries and concepts. And I would also say, continue to use things like ChatGPT. Like that is shown to be like a really useful resource in coming up with like usage examples and things like that as well. But definitely continue trying out the latest and greatest of AI developer tooling. I think these are these things. This whole like ecosystem of tools are going to change the pace at which you're able to learn, acquire, integrate, and apply new knowledge. And professional software developers are doing it, but you as the newbie have kind of this advantage of not being not having like large parts of your brain mass devoted to understanding tools that may not be applicable anymore. So that is to your advantage, and by kind of diving headfirst into building stuff and using the best tooling that's available, I think you can quickly ramp up and get up to speed.
Perfect. Well, on that note, I think that was a great way to conclude. A lot of good advice there. And want to thank you, Amanda, Bayang, and Luke. It's been an honor to have you here and paint a pretty exciting picture about where we are today, but even more so where we go from here. So thanks again. Hopefully everybody enjoyed the talk. I certainly did. Have a good day. Take care.
Thanks for having us.
Great to see you all.